Welcome back to my channel. My name is Ramsa Jahangir and my station number is 16300. In today's lecture, we are going to discuss what is linearity and what's the difference between linearity and non-linearity, what is signal decomposition and the types of signal decomposition and their advantages. So, what is linearity? Linearity is basically the first order system is called a linear system whose power is equal to 1. A linear system's power is equal to 1. For example, Ohm's law, Hooke's law, and multiplication with a constant. A non-linear system is that whose power is greater than 1, or we can say power is not equal to 1. Examples of non-linear system are, we say when v power is equal to v square r. Here the square indicates power is not equal to 1. Now we will discuss what is signal decomposition. Signal decomposition we can say is superposition, and superposition is multiplication followed by addition. And use superposition theorem to decompose complex signals into simple signals for easy analysis. This is called signal decomposition. We decomposed complex signals into simple and signals for the easy analysis, and this process is called signal decomposition. When we go from simple signals to complex signals, this is called synthesis. Synthesis is the process of artificially creating the signals. So now we'll discuss the types of signals. There are basically 5 types. Number 1 is impulse decomposition. In impulse decomposition, we divide the signal into pulses and samples into n pulses. An advantage of impulse decomposition is that we can create the signal once it is decomposed. Now the second type is step decomposition. In step decomposition, we divide the signals into steps, means n samples into n steps. And the advantage of step decomposition is that it can be used to analyze adjacent different signals. Now the third type of signal decomposition is even odd decomposition. In even odd decomposition, as the name indicates, we divide the signal into even and odd parts. In even part, we get such a signal which increases at 0. and the formula for even decomposition is x of en is equal to x of n plus x of n minus n divided by 2. And the formula for odd decomposition is, we will take a signal which flips around 0. Anything which flips around 0 is an odd signal, odd decomposition. And the formula for odd decomposition is x of n minus x of n minus divided by 2. Now the fourth kind of decomposition is kind of decomposition is interlaced decomposition. In interlaced decomposition, we divide a signal into even and odd signal indexes. For example, x of n is equal to 1, 2, 3, 4, 5 and 0 to test 2. So the even part will be, even signal index will be 0, 2, 0, 4, 0 and the odd signal index will be 1, 0, 3, 0, 5. And the advantage of the interlaced decomposition is that it is the basis of a very important algorithm in DSP. Which is FFT, fast Fourier transform. Last kind of signal decomposition is Fourier decomposition. And if you divide a signal into sinusoid waves, which is cos and cosine and sine waves. And advantage of Fourier decomposition is Laplace transform. It is the basis of Laplace transform. Z transform and Fourier transform. It is also a very extensively used type of decomposition. Thanks for watching.